In this video, I'm going to talk about significant figures. But first, I want to talk just a little bit about uncertainty. So if we have this graduated cylinder here, and I have 3 different people tell me how much water is contained in this graduated cylinder, I'm probably going to get 3 different answers. So you can see right here is the water level. So each person that comes up and reads this water level, they should probably see that it is definitely between 4 and 5. We can definitely see that. So everyone should say it's 4 point something. And then these next little tick marks, they're dividing this cylinder up into 0.1. So this is 4.1, 4.2, 4.3, 4.4, and so on. So hopefully everyone should also be able to see that it's somewhere between 4.3 and 4.4. So everyone's second digit should be the same. Now, you might think this is where you stop measuring, but actually you want to measure one number beyond where the scale ends. So let's just say that these little tick marks weren't there and we just had this line here and this line here. You wouldn't say, oh, the water level is exactly at 4 or the water level is at 5. You would say you would estimate this level right here. So you might guess 4.3, 4.4. So we're going to do the same thing in this little space here. So we're not just going to stop at 4.3. We're going to say, all right, it's definitely 4.3, and I'm going to guess where I really think the water level is ending. So someone might say, I really think it is right on 0.3. So I'm going to say the water level is 4.30. Another person might look at this and say, well, I think that it might be a third of the way between 0.3 and 0.4. So they're going to say 4.33. And then maybe someone else, they forgot you're supposed to read at the bottom of the meniscus and they were reading right here. And they might say, I think it is almost 4.4. So I'm going to say 4.39. So we have 3 different values for the measurement of the volume of this, the volume of this water. These 2 numbers here, these are the certain numbers. And then this number here is the uncertain number. So when you're reporting measurements, you should always report all of the certain numbers, of course, and then you should report your first uncertain number. And these are significant figures, or you'll see the abbreviation sig figs. Here I have 5 different numbers, and I've listed how many sig figs each of the numbers have. So take a minute and just kind of pause the video, think about why did I say that B has 3 sig figs and that C has 3 sig figs, but E only has 2. So think about that, and then we'll go through the rules for significant figures. All right, our first rule for significant figures. Our first rule is non-zero. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Non-zero numbers are always significant. So basically, figuring out whether a number is significant or not just comes down to the zeros. So we need some rules for the zeros. So there's 3 different rules for the zeros. We could have 3 different types of zeros. Our first type of zeros would be leading zeros. Leading zeros. What I mean by that is D is a great example of leading zeros. Zeros come before anything else. Leading zeros are never significant. And the reason why is we could easily write 0.029 in scientific notation. So we take our decimal and move it 1, 2. So we could write 2.9 times 10 to the negative 2, and look, there's no more zeros. So leading zeros never significant. Second type of zero, captive zeros. So captive zeros, let's see, B is a great example of captive zeros. It's just a 0 between 2 other numbers. Now, it doesn't have to be just 1 0 between the 2 other numbers. I could have had, instead of 2.09, I could have had 2.0009. All of those zeros would be captive. Captive zeros are always significant. And then our third type of zero are trailing zeros. Trailing zeros just come at the end of the number. Trailing zeros are sometimes significant. So look at C and E. They both have trailing zeros. One has 3 sig figs, the other has 2. So what's the big difference between those two numbers? So the biggest thing that jumps out at you is the fact that C has a decimal place and E doesn't. In fact, that is the reason why we have 3 sig figs in C and only 2 in E. If you have a decimal place and you have trailing zeros, those zeros are significant. So basically, if you see trailing zeros, look, all right, do I have a decimal somewhere in my number? If you do, then those zeros are significant. If you don't, then those zeros are not significant. We actually have one more rule for sig figs. Rule number 3 is for exact numbers. Now, these examples I have written up here, they're not examples of exact numbers, but exact numbers have unlimited sig figs. So basically, that means you just don't worry about sig figs when you're looking at a number like this. An example of a number that has unlimited sig figs would be, let's just say I have 20 quarters. That number 20, that would have unlimited sig figs because I could have counted my quarters and found out how many quarters I have. I know how many exactly I have. Another example of something that has unlimited sig figs is a conversion factor. So 12 inches equals 1 foot. That is an exact conversion, so we're not thinking about them in terms of sig figs. They would have unlimited sig figs. Okay, so here are some examples. Why don't you go ahead and try them, and then as soon as you think you have all the answers, come back and see if you got them all correct. All right, A, 3 numbers. We know that definitely those first 2 nines are significant. So the question is that 0 at the end. Is that significant or not? Now it's a trailing 0, so trailing zeros are sometimes significant. Now this is a trailing 0 with a decimal. So trailing 0 with a decimal, it is significant. So there's 3 sig figs in that number. All right, sample of sodium chloride weighs 0.095 grams. These are leading zeros. Leading zeros are never significant, so 2 sig figs. And remember, we could have rewritten this as 9.5 times 10 to the negative 2 to get rid of those zeros. The speed of light is 2.99 times 10 to the 8th meters per second, so we don't have any zeros in that, so it's 3. Now, you might be wondering why we don't include this piece into counting our sig figs. Well, why don't we just convert this out of scientific notation? So that's the same thing as this number right here. Now notice we have trailing zeros, but we have no decimal place. So all of those zeros are not significant, so 3 sig figs. All right, the distance between 2 points is 11 inches. Now this has 2 non-zeros, so that would be 2 sig figs. There are 8 apples on the table. Now you might be tempted to say 1 sig fig, but actually that's not correct. It is unlimited sig figs because we can count these. And then the same thing for F. There are 202 students in the classroom. We can count that, so unlimited number of sig figs. All right, so we've learned the rules for significant figures and how to figure out how many sig figs a number has. But really what we're interested in is actually doing calculations. So we want to be able to do a calculation and then figure out how many sig figs our answer should have. Now when we are multiplying or dividing, that's not subtracting, that's dividing, the number of sig figs in our answer is the same as the measurement with the smallest number of sig figs. And we'll go through an example to show you what that means. It's really simple. So here's our calculation right here, 2.85 times 1.1. So 2.85, 3 sig figs. 1.1, 2 sig figs. So all that sentence is saying is, all right, identify how many sig figs each of your numbers have. Your answer has 2. It has the number of sig figs that is the smallest. So what you would do is you would calculate this maybe in your calculator on paper, and you would get 3.135. But we can only have 2 sig figs, and this number has 4. So we're going to keep this one and this one. Now what you want to do with this number here is make sure that this is less than 5, otherwise you'd have to round up. So our answer is 3.1. Alright, take a minute, try these practice problems, and then come back and see if you got the correct answers. Alright, I've written under each of the numbers how many sig figs it has, and then I've written off to the right what you would get if you just typed it into the calculator. So A, we see that A, this is the smaller number of sig figs, so that means our answer needs to be in 2 sig figs. So our answer would be 22. We had to round that 1 up to 2 since this is an 8. It's 5 or greater. Alright, 4 sig figs, 5 sig figs, so our answer should have 4. So 1, 2, 3, 4. Our next number is 0, so we don't need to worry about rounding that last 0 up. C, 1 or 2 sig figs, so our answer should have just 1 sig fig. So our answer is going to be not just 2, we have to put the placeholder of 0, so 20. Alright, 1 sig fig for our answer here, so we are keeping this. This is 5 or greater, so we're going to round that up to 80,000. E, we have 1 sig fig, 2 sig figs. We get 2.72 repeating, so we're going to round just to one number. So this number is 5 or greater, so it's going to round up to 3. Now, this next one is kind of an interesting situation here. We have 2 sig figs, 2 sig figs. Our answer comes out exactly to 5. So rather than just writing 5, we're just going to add on 0.0 in order to keep 2 sig figs. Okay, and then our last one, oh, I didn't write how many sig figs, 3 and 2. So our last one, our answer should have just 2 sig figs. So this is our last sig fig. This number is less than 5, so it would be 31. So we just finished the rules for multiplication and division. Now we're going to talk about addition and subtraction. So for addition and subtraction, the number of sig figs in our answer is dependent on what the last significant figure is in the answer, or in the numbers that we're adding together. So addition and subtraction, it's a little bit more confusing, but just going through example problems makes it pretty clear. Now, if we look at 8.35, our last significant figure is the 5. 2.1, our last one is the 1. Now, what we want to do is we want to look at, of the ones that we've underlined, which one is furthest to the left? And that would be this right here. So a good way to do addition and subtraction is to actually just line up the numbers. So you can see this underlined 1 is further to the left than this underlined 5. So you just do your calculation how you normally would in your calculator. 10.45 is what I get. So now our answer has to be rounded to that spot. So that's the spot just to the right of the decimal. So we get an answer of 10.5. Now notice something. This number right here has 3 sig figs. And then the numbers we're adding together, 3 sig figs, 2 sig figs. So with addition and subtraction, you don't necessarily figure out the fewest number of sig figs, and that's what your answer has. You have to go based upon where the location of these last significant figures are. And the same exact process holds true for subtraction. Here we have a few examples, so go ahead and try these out on your own, and then come back and see if you got the correct answers. Alright, I've underlined the rightmost significant figure, and then I've written down what you would get if you just typed it into a calculator. Okay, so our answer would have to be rounded to the tens place because of the 2 underlined numbers, that's the one that's furthest to the left. So it has to be rounded to this number here. So it wouldn't be 8, it would actually be a 9 because that 6 makes that 8 round up to 9. Okay? In this one, we would have to round to the tens place again, and this would round to 30. Our next one, let's see, which one's furthest to the left? This one right here. So our answer would have to round to this spot right here, and then this number is 5 or greater, so we'd get 35.7. Okay, and then for this one, we would have to round to this spot here, which is right here. We have a 5 after the decimal, so this would round up to 82. Okay, just a couple more example problems. Now, in these example problems, we're putting together multiplication, division, addition, and subtraction. So go ahead and figure these problems out, and then come check back and see if you got the correct answers. Okay. Alright, so with this problem here, the first thing you should do is work with the one in parentheses first. You'll see that we need to have our significant figure, our last significant figure in the hundredths place. So we're going to just solve for what's in parentheses first, so 0.12. So now we're multiplying. So now we actually want to think about how many sig figs each of our numbers has. So this has 4, this has 2. So we're going to multiply these two numbers together, and then we're going to round to 2 sig figs. So in the calculator, we'd get 2.6496. We're going to round to 2 sig figs, so that's 2.6. For this one here, we're going to do what's in parentheses first. Now, notice this, 3 sig figs, 3 sig figs. But we're just going to go ahead and keep more sig figs, and then you can deal with that at the end. Because we don't want to round, if you have a problem that's maybe 10 steps long, you don't want to round at every single step because your answer might be way off at the end. So you always want to do this rounding at the very end. So we're not just going to write 24.8, we're going to write 24.875. Okay? And then we're going to subtract 10.1. So there are the two ones we're looking at. This one is further to the left. So that means our answer needs to be in the tenths place. So our calculator would give us this, but we need to round to the spot here, so it's actually 14.8. All right, our last one, we're subtracting. We're going to have our answer significant to the ones place. So this number here, it's significant to the tens place, so we're just going to put a decimal to make it significant to the ones place. All right, and then 11 times 10 is 110. They both have 2 sig figs, and actually there's no decimal here, so this answer has 2 sig figs as well.